Okay, so when you upload a picture to Facebook, it can now tell you automatically who is in the image. So here we have machine learning. You have an input layer, which is basically all the features of a face. So you have the nose, the ears, the mouth. You have a hidden layer, which is like the human brain. So it thinks about things, but it works in numbers. So 0 to 1, stuff like that. And it produces an output, so who it is. So just like a human, it needs to train and it needs to test. So it trains using images of David Beckham. And then when it comes to the test of who is this, we know it's David Beckham because we've learnt that from training. So it's the same as a human mind. Each Facebook account has an average of 214 photos, which have been labelled by humans. Because we don't have access to every single photo on Facebook, we're going to use a database online called Faces in the Wild. This is like 13,000 different images of like many people, and we're going to use this. So here's the start of our program. The first thing that we're going to look at is this line here. So we've fetched the data. So obviously it's an online database that we can just fetch the data from. So if we go up to the function here, you can see that we're fetching people with a minimum of 70 faces. So obviously this is the database here. You have so many people in there, people like Tony Blair, who has like 150 images, but then other people only have 2 images. And you can't, like this guy has 3 images. You can't do the training accurately enough on just 3 images of someone. So we're only looking at people that have over 70 faces. Just like on Facebook, your closest friends, you'll have more pictures of them than you will of people that you don't know. So Facebook is more likely to look at the people that you're close with first before looking at other people. All that has done is output how many samples we have. So we're using 1,288 samples, the height and dimensions, features, which is just the amount of pixels we've got, in classes, which is 7. So we're looking at 7 different people. We can't use every pixel as a feature, so we can't actually use this number because there's a lot of noise in the background of these images. So we need to use a PCA algorithm, and this allows us to create eigenfaces. So these are eigenfaces, and it starts from the top left, 0, goes all the way to 99. You can set this amount of number, but the more you have, the more noise you get. So you can see the faces get less detailed. Which is bad because you get more noise. So you don't want to go too far, otherwise you'll overfit. So you can use a specific weighting on each of these eigenfaces, which match all together to create each database sample. So for this face, you might use 0.2% of this eigenface, 5% of this eigenface, etc. Now we can use these eigenfaces as inputs into our machine learning algorithm. So now we just train the model like you would normally train something. It basically just looks at all the images and tries to get the right answer. And if it doesn't, it just makes it better and learns from it. So it's basically learning. And then we make the prediction. So now it's actually testing itself on test data that it hasn't seen and seeing if it can get it right. Now let's have a look at that test data and how it got on. See that we've got an 86% precision, which is pretty accurate, pretty good. You can see that some people aren't as good. That might be because there isn't as many photos as the other people. And if we just scroll down again, you can see the test results. So you can see test 0 to test 321. So here you can see this was our first test that we did. It was testing for George, and it found George. And this is the face that it was using at the time. Obviously, Facebook will be able to pull phone numbers, location, friends' information. Facebook ran the algorithm and it wasn't one of these people. Then what would it do? It would look at a more generalized area of your friends. So it might look at people within your gallery that have less than 70 pictures per person. So let's go with 50, for example, and run this code and see how it changes. So as we reduced it to people that have just over 50 images in the database now, we get 12 people instead of 7. We're still getting the same around average accuracy, but obviously it is slightly better with the more photos that you have per person. So if we scroll down, we can have a look at our test results as well, and we can have a look at, say, test 38. So let's have a look at test 38. So as you can see, this was the image it used for the test. It predicted correct. You could pull a phone number again, location, the amount of friends she has on Facebook, different stuff like that. So it just shows how powerful this face recognition software can be. And this is just a simplified version compared to what Facebook actually has.